Hey guys, so today we're going to be reviewing functions. So first, let's talk about what a function is. In order to define a function, we first must recall what a relation is. So a set of ordered pairs can be shown in a table, a mapping, a graph, or expressed as an equation. We call the x values the domain, and the y values are the range. A relation with distinct points, that's like dot, dot, dot. If you graph just a bunch of ordered pairs, that's called discrete. But if you connect them with a curve, that would be called continuous. So if we look, this would be continuous. This would be discrete. That's the difference there. That might be a new term for you. But relation, you should have been familiar with. You should know what a function is, and here it is. A function is a relation in which each element of the domain is paired with exactly one element of the range. So if we look at a couple of examples, I've got the ordered pairs 1, 2, 2, 3, 4, 2, 111, whatever, doesn't matter. If I look at the x values, the domain, they're all unique. None of them have duplicates for the output. We're good. Here, if I look at this one, I have 1, 2, okay, 2, 3, and 2, 111. Well, 2 maps to two different things here, so the domain doesn't have, is not unique. It's not unique here. So we can't have this thing going on. 2 can't go to two different things. X values do not repeat. That's key. All right, so if we have a graph of the function or relation to see if it's a function, we just need to look and see, can a vertical line pass through this only once? So let's just draw some random thing here. Doesn't matter. If I'm looking at this and I visualize a vertical line, if that vertical line will only go through, these are arrows, they're not points. If that vertical line will only go through one point on that relation, then that relation is a function. So yeah, that one works. Let's draw something else. How about a circle-ish kind of thing? If I look at this one, I'm passing through 2 points in a lot of places, but even if it only happens once, so even if we do something like this, and then put a dot here, that would still not be a function because right at this point, it fails the vertical line test. So it only has to happen once. If it happens once, it's not a function. Okay, let's just practice domain and range. We're going to do a couple of these. It really should be familiar to you. So these are sets, so let's put it in set notation. So I'm looking at my x values. I've got a -1, I've got a 0, I've got a 4, I've got a 6. Doesn't have to be written in order. Now I'm looking at my range. I've got a -9, I've got a -5, got a 3, and a -2. That one's definitely not in order, but that's perfectly fine. Now, if I look, do any of my x values repeat? They do not. So is this a function? Yes, it is. Let's look over here. That's my domain. Sets of 5, -3. I've already got 5. I don't write it twice. 8. Oops, forgot to close that set. Sorry. The range would be 2, 4, -6, and 0. Okay, let's look at this one. Is it a function or not? Well, 5 goes to 2 and 5 goes to -6. So right here, that's a no. That ain't no function. Still a relation because a relation just has your domain mapping to your range. Doesn't have to have any special conditions, but it is not a function. And we can represent it in different ways. I'll do one of each of these. So in this one, these are discrete, by the way, since we only have individual points. We don't have a continuous graph to look at. That's my domain, 7, 2, 0, -4, and my range. You should already be able to tell me if it's a function or not. It's -8, 3, -1. And again, we don't repeat. We already have 3 written. Is this a function? Yes, it is. Because, well, all my x values are different, so they definitely don't repeat. So we're good. Let's look at this one. It's my domain. Well, my domain is my x values. So -4, -2, and 5. That's my range. 0, 3, 7, and 9. Okay, is that a function? Nah. Look at the mapping right here. 5 goes to 7, or it goes to 9. It goes to both of these things. So there's no, not a function. You can also look at the size of your domain. There's 3 elements in my domain. There's 4 elements in my range. You can't have more elements in your range than your domain. That's not a function. Looking at the picture here, this is a function because none of the x values are repeated. 2 goes to that, 8 goes to that, 13 goes to that, and 17 goes to that. Even though both 2 and 17 go to the same element in the range, doesn't matter, it's still a function. Okay, here's a discrete set of numbers. Remember, if we're looking at a graph, you can use your vertical line test. Now you make a bigger vertical line. I'm going to, hang on, let me lock that. If I'm going through here, yeah, that's good, that's good, that's good, but right here is a failure. So just by looking at the graph, the vertical line test, we can tell this is not a function. I'm not going to do the domain and range on all of these, but I will do it on this one and this one. Maybe we'll just talk about that one. So my domain, well, that's my x values. 1, 2, 3, so -3. Um, 0 and 2, my x values. My range. Oh, I forgot this one over here. I didn't see him. Hang on, let me go back to my domain. And let's see, 1, 2, 3, 4. Sorry, OCD people, I put random spaces. Let's see, it goes 1, 2, 3, 4, 5, so -5. -2, -1, I said 1, 1, and 4. I'm just going bottom to top because that's easier for me to see. So again, bigger range than domain, so that's definitely not a function. Is this one a function? Absolutely, it's passing that test. Now, what's my domain here? You might have guessed it, everything. Negative infinity, but I have an infinity symbol on this one. Negative infinity to positive infinity. That's my range, same thing. So that's why we needed to make sure we knew what interval notation was from last week, because we're going to be using it a lot from now until we die. Okay, let's just look at these two. Are these functions? Well, is this a function? Pass the vertical line test, so yes. Is this one a function? No. Is this one a function? No. And now we have equations, okay? So you'll have to think back to Algebra 1. What is the domain of this? What can I plug into here? Well, you should remember that every single polynomial has all real numbers as its domain. So the only time we're going to come into some issues is if we don't have polynomials. If we have a rational equation, that's with x in the denominator. If we have square roots, that's with x under square root. Something that would force us not to be able to use all real numbers. Now, you probably don't remember what the range is going to be on this one, but if you think about it, the smallest value this can be, if I plug in a 0, well, either smallest or biggest, we don't know, the maximum or minimum value, if we plug in 0 for this, it will give us 3. So I'm either going to start or stop at 3. And now, yes, you should remember that it's going to go upside down, so that's going to be the maximum value. It's going to be negative infinity to 3. So guess what? I told you about this calculator. Let's use it. Mode 5, 3. -1. There's no x's, so 0, 3. It has my roots. We don't need those, but it's a maximum value at x is 0 of 3. So it tells you that's a maximum. So you don't have to remember if it's up or down. So it's going to go from, remember that we go from smallest to largest. So it's negative infinity all the way up to 3. Oops, that's weird. 3. Do we include it? Yes, we do. So if it's written as an equation, you have to do a little bit more thinking. Now, you should be able to visualize these at least a little bit. You should know that this is a quadratic that's going upside down. You should know that this is a linear equation. So that's going to be all real numbers for domain and range, and yeah, it's going to be a function. And of course, this is a function, and this is also going to be a function. That's quadratic on the left. That's a linear equation on the right. Now, what about these two guys? If you can't visualize those, well, graph. It says y is -7. So down here somewhere, let's say that's -7. And y is always that, so it's going to be a flat horizontal line, just like that. Going on forever in both directions. Just lays right and arrow. So is that a function? Yes, it is. What's my domain? Well, I can plug in any number I freaking want to, can't I? What's my range? Well, what's always my y value? It's -7, that's it. Well, this is perfectly fine to be a function. Every single item in your domain maps to one output. One item in your range, that's the only thing you have in your range. Okay, let's look at this guy. Lovely vertical line right there. Yeah, beautiful. X is -1, so let's stick that right there. X is always that, so it's going to go like, well, no matter what y is, x is -1, so something like that. Is that a function? Absolutely not. It's a vertical line. And here your domain will be -1 and range will be all real numbers. Let's talk about evaluating and function notation. So y equals 2x plus 7. Sure, why not? But more commonly, we're going to use function notation. We talked about this last year. We talked about the year before. You should be familiar with function notation. So I used f. You could use literally any letter, but f is what we commonly use for function. You could name it anything. You can name it z of x if you really wanted to. It has to be an x, though, because it's using x in here. If this were, say, 2c plus 7, it would be f of c. So whatever your input is this letter. Whatever you want to name it is that letter. This is not f times x, this is read as f of x. If you say f times x, you should just find a wet sloppy fish in the dumpster and smack yourself in the face with it. So what is the input? X. What's the output? F of x. Yeah. Here's an example. F of x is 2x plus 7. It wants us to find f of negative 3. So what's going on is replacing x with negative 3. So that's what we do. Anytime you need to evaluate something, anytime you need to replace a variable with anything, put parentheses. Just do it. Every single time. You have two variables, use two sets of parentheses. Whatever. Anytime you need to replace something, put it in parentheses. So let's do this now. What does this say to do? Remember, if it's written right next to parentheses, that's understood multiplication. So that's negative 6 plus 7 is 1. So we'd read this as f of negative 3 equals 1. Negative 3 is my input, 1 is my output. We'll do a couple examples, not too terribly many. Let's see. We'll take a fraction. We'll take these two as well. Let's do it. Oh, yeah, why not? I'm not going to make you show every single step anymore. We've talked about order of operations. You still suck at them, but I'm not going to make you show your work. Just as long as you show the setup and the solution. So if we look here, number 2, I kind of wrote over that. Let me see, which function is it? Is it f? Yes, it is. It says f of 3/10. You must write it down. So f of 3/10 equals negative 5 times 3/10 minus 14. Notice how I put it in parentheses. Now, whenever you're evaluating something, you don't mess with the left side. That's just telling you what you did. This is going to be this thing equals some number. This is just an expression here we need to simplify. So you can do that however you need to do it. That would be negative 3/2 minus 14. If you know 14 is 28/2, so that's negative 31/2. So let's go to mode 1 and just type it in. Now, if you don't have this particular, oops, pay attention to what you're doing. Make sure you get out of the denominator. Now, if you don't have this particular calculator or a calculator that does math type, you don't have to do it by hand. But if you don't, as long as you show the setup and the solution, I'm good. Let's look at this one. So we have multiple x's here. So that means we need to put parentheses twice. So g of negative 4 or negative g of 0.4 equals negative 0.4 squared. Can you write 0.4? Sure. Plus 9 times 0.4 minus 1. I'll be back in just a moment. Okay, sorry about that. It's nap time and I'm loud. So we have the setup. G of 0.4 equals, plug it all in, make sure you use parentheses. Then you can do it. Again, calculator is perfectly fine. It's going to be negative 0.16. I'm not going to write the zeros. Plus 3.6 minus 1. So yeah, definitely want to use a calculator on this one. But if you just put it in from here, that would be fine as well. Negative 0.16 plus 3.6 minus 1. That's, so yeah, 61 over 25. That's what I'd like to see. It's going to give you 2.44. And yeah, I want 61 over 25. I'll write 2.44 though, because some of you, if you don't have a nice calculator, might not be able to tell me that that is 61 over 25. Ideally though, we don't like we don't like decimals. Unless we're dealing with money or something else, we want fractions. They're easier to work with. So again, you can just type this in as you see it. Negative 0.4 squared plus 9 times 0.4 minus 1 equals 61 over 25, done. So you could write this out and give me this. Don't just give me this. No, that's not sufficient. Write it out. I need to know that you know what you need to do. And just plug that in here, f of 1 minus f of negative 4. So that means we have to do two different things. So let's do f of 1. Let's see. I'm going to actually just write it out. Negative 5, I'm plugging in 1 minus 14. I need to subtract. What do I need to subtract? This whole dang thing. So put it in some parentheses or brackets or something. Whenever it's a longer expression, I like to use brackets just because I'm probably going to use parentheses inside of there whenever I replace x. So I prefer brackets and double parentheses. Double parentheses would be fine as well. And we're plugging in negative 4 this time. Minus 14. So order of operations, we do this first. Let's do it. And again, if you have this set up, you can give me the solution. So that's going to be 20 minus 14 is 6. That's negative times negative is positive. 20 minus 14 is 6. You could write out a whole extra stuff here if you want to. That's fine as well. Whatever you need to write. So I'm going to get rid of my multiplication. Negative 5 minus 14 minus 6, and that's negative 25. And that would be the actual answer. As long as you have this, you can type it in, you should get the same thing. It's too much typing. So let's look at what's going on here. We're multiplying 2 times g of 12. So we're doing 2 times g of 12. Let's see, that's negative. Put the freaking parentheses. Don't not put parentheses. Every single time you got an x, put parentheses in place of the x. Yeah, so this one I'm just going to type in because it's going to be larger numbers. 144 plus 108, or negative 144. Yeah, so let's just do it on the calculator. 2, you don't have brackets on here, so just use the parentheses. They are the same thing. Oh, sorry. Type exactly what you have. Negative and then 12 squared plus 9 times 12 minus 1. Close the brackets, which in this case is a parenthesis for us, and that gives us negative 74. Sure, why not? Okay, negative 74. There we go. So this is what I need to see. You have it written out, and the answer. You don't have to show all your work. Now, if you don't have a nice fancy calculator, you're going to have to show all your work. Because I definitely want fractions. I don't want decimals. Okay, let's see. More of these. We'll do one of each. We'll do a P and a Q. So you suck at doing fractions, definitely use a calculator here. Do 7 and 8. Well, yeah, why not? 1/2 minus 4/3, and that's times, and x is negative 9/16. You can use a calculator if you need to. That's going to be 1/2. Let me get some more room. Half. Not messing with that. Minus. That's going to be 1. Oh, it's a negative, so that's going to make it a plus. Negative times negative is positive. That's going to be 1, and that's going to be 3 times 4 is 12, which is 7/12. Feel free to use your calculator because I don't think you're that great at fractions or basic arithmetic, in fact. So just use your calculators, but make sure you give me a fraction and not a decimal. I will not take decimals. And you get 5/4, so I screwed up something. See, that's why you want to use a calculator. Let me write it down. Let's see. Those both have a 3 in them. That's a 1. Oh. Wait, what? Sorry, guys. I got to figure out what I did. Half minus a negative, so that's plus. Did I type it in right? That's 3 over. Oh, why did I get a 12? That would be the issue. Sorry. It's 3 over 4, not 1 over 12. Sorry. Oh, yeah. Okay. My bad. 3 over 4. This is why you definitely want to use a calculator. That's 2 over 4, so 2 plus 3 is 5 over 4. Apologies. If you don't use a calculator, definitely write it out. Now, Q of 5, that is absolute value of 3, use a parenthesis, 5, minus parenthesis, 5 to the third, absolute value. Type it in there. You have it set up. You can do shift height for the absolute value. Ask me where it is on your calculator, because again, I told you to get this calculator for a reason. Okay. All right. Oh, let's work backwards. Let's do this. It says if f of x is negative 62, find x. So this time they're giving us the output, and we need to figure out what the input is. Negative 62 equals 3x plus 19. Again, you should know how to solve these, but it's questionable. This does solve these for you, so let's do it. Negative 62, alpha calc is the equal sign, 3 alpha close parentheses is the x, plus 19. Do not hit equals. Shift calc. Solve for x. This is not your answer. This is whatever the calculator is going to guess at, so just hit equals. Oh, and it tells us negative 27. Okay. So x equals negative 27. That's it. And here's a word problem. So let's translate what this is meaning. It says find P of 24 and what does this represent? Owen paid landscaping company $108 for an initial lawn treatment, then $74 per month thereafter. Function P of t equals 108 plus 74t represents the total amount of money he will have paid after t months. So our input is months, it's t. Our output is monies. How much money has this dude spent? So let's evaluate this first. So 108, let's calculate, plus 74, open parentheses, 24, and let's just evaluate that. 108 plus 74 times 24. 1,884. Now, money is one case we would use decimals on, but we didn't get decimals. So. Again, this is our output is P, the price he paid, the amount of money. So this is the money. So what does this represent? This says Owen paid $1,884 after 24 months. Well, not after, but for 24 months of work. So this dude spent $2,000 to get his lawn taken care of in just 2 years. You can buy a nice riding, you can buy a robot lawn mower for $1,000 and just let it do its own thing. Anyway. Okay, last thing. We don't always evaluate at a number. Sometimes we evaluate with an expression. So I'm going to do 16 and 20 and call it a day. So let's see what's what here. Oops. Hang on a second. We're evaluating this. What are we evaluating? Hi, what's your name? Your name is F. Where's F? F is right here. Hi, F. That's G. Nice to meet you. -4, open a parenthesis. What are we putting in place of X? This thing right here. So do it. And then +9. Now, if you go to grab your calculator and type it in, there's a C right there, but that's not going to work for you because right now C is assigned the value of 0. These are just numbers that can be stored. Yeah, so no, don't try and do that. That's not going to work. You actually have to work this one out. Distributive property. -4C minus 8 plus 9. Combine like terms. -4C plus 1. Done. That's it. It's not -3C. No, you can't combine these. That's it. They're not like terms. Too many of you are trying to combine these sort of things. It's just give me a headache. If it's not like terms, don't try and combine it. All right, so now we have this huge thing right here to deal with. So let's do it. I'm gonna move my face too. Get up there. Okay. First, G of 2n plus 1. So let's do that. Hello, G, who are you? You're G. Oof, this is gonna be terrible. So, this is gonna take some scratch work probably. I have x squared, so I'm gonna open up a parenthesis, 2m plus 1 squared. And I'm gonna subtract 5 from that, minus this whole f thing here. 3m minus 7. So negative 4 times 3m minus 7 plus the 9. Okay, we're subtracting this whole thing. So this is the setup. We got to work it out. What does it mean to square something? It means to multiply it by itself. So I'm going to do that over in this area here for some scratch work because, well, I'm going to run out of room if I try and do it right there. Now in your problem, you can do it, you could do it down here, that's fine. But I'm going to do it over here so I don't run out of room. So to square something means multiply it by itself. So rewrite it first. Don't try and just do it, rewrite it. So 2m plus 1 times 2m plus 1. Okay. I'm just doing this piece right here. So this is what I'm doing in blue over here. Distributive property, that's 4m squared plus 2m then plus another 2m plus 1. Now, those of you that are fluent, you might remember that this is a perfect square trinomial. It's going to be this squared plus 2 times this plus this squared. That's fine. If you don't need to do it out, you don't need to. It's up to you. But for the most of you, write it out. So combine like terms, 4m squared plus 4m plus 1. So I'm going to replace this with this expression because they're equal. I just did this and got that. So 4m squared plus 4m plus 1. So that was my scratch work. Minus 5 is still there. Now I'm going to do what's inside the parentheses. Minus distributive property, negative 12m plus 28. I'll get the plus 9. Check my work. 4 times 3 is 12, and it's going to be negative. 4 times 7 is 28, and it's negative. Negative makes it positive. Okay. This is a bracket, by the way. Okay. Let's combine like terms. Let's combine like terms over here. I've got 4m squared plus 4m minus 4 minus, combine like terms, negative 12m plus 37. So take this step by step here. It's a long one. Let's distribute that negative. So 4m squared plus 4m minus 4. And all this negative is going to do is change the signs. Plus 12m and minus 37. Combine like terms again. So I got my regular old numbers here and here. I got my, don't drop off the m because that would be terrible. You do all this work and you get it wrong because you forgot an m right here. That would be just horrible. And you got your m's right here. Of course, if you showed your work, I'd probably give you full credit. Yeah, that's just a simple error, copy error. I don't take off points for that. 4m squared. 4m plus 12m is 16m. Negative 4 and negative 37 is negative 41. Are we done? I think we're finally done. Look at that. We don't have anything else we can combine. Remember, we're evaluating here. We're not solving. There's no equal sign. There's no, this is equal to a number. So don't think you have to get m by itself because you're not solving, you're evaluating. You're just trying to get this expression to a simplified form. So that's it, people. That was a long one. The good news is this should have all been a review. The bad news is you probably forgot all this. So watch this video like 20 times, you should be good to go. All right, see you next time.